Okay, so let's look at some of these questions. We have that for a parabola, it says is defined like this. I guess as it's written, it's not quite a parabola. I mean, it's a quadratic function whose graph is a parabola, I suppose. And then for the values of find the values of k so that the graph y equals p of x, so that the parabola is always above the line y equals minus 1. It's always above y equals minus 1. Yeah, so first of all, you might be tempted to assume that k is positive and that the graph will be smiling, but be aware that it could also be negative and it'd be going down. Okay, but can you see that in this problem, for it to always be above the line minus 1, it can't be negative, because if it was negative, it would have to cross it going downwards. So basically, you're looking for a parabola that's facing upwards, so k is greater than or equal to 0. So it's not equal to 0 for it to be a parabola. Okay, and for it to stay above that thing, you might have to do a calculation. So, for example, I'll go into the calculation in a minute, but if this is a question that you're stuck on, I mean, you don't necessarily have to go straight to the general calculation. You could try some values of k, right? For example, the simplest value of k I can think of right now is 1. So if k was just 1, x squared minus 2x would have x-intercepts at 2 and 0. So it would look like this. Okay, and the question is, does it go under minus 1? Well, the maximum occurs at 1. So when you put 1 into k equals 1, that's 1 minus 2. It'll actually just be on minus 1. Okay? Yeah, I guess when it says always above, it means it can't be on minus 1. Okay, so this is suggesting perhaps, yeah, so 1 just barely doesn't work, right? Then if you try k equals 2, you have a common factor of 2x. So then you have an intercept at 1 and 0. Okay? 0 and 1. And the maximum occurs at a half. Okay, which will give you negative a half. So k equals 2 works. Okay? So the answer could be just basically all the k that are strictly greater than 1, or something like that. So that's a good guide to have when you're solving it. And what do you want? You want basically kx squared minus 2x to be greater than or equal to minus, so not greater, so strictly greater than minus 1 for all x. Okay? Yeah. Yeah, and actually doing those examples was pretty good because that procedure works in general, right? See, if you wanted just to find the intercepts, or if you knew the formula for the maximum, the x value is minus b on 2a or whatever, you could do that too. But if you knew that the intercepts would be 0 and 2 over k, okay, then the maximum would happen at x equals, or the minimum, sorry, it will happen at 1 over k, halfway between 2 over k and 0. Okay, and so if you sub 1 over k into this expression, you get k times 1 over k squared, this all squared, which is 1 over k squared, minus 2 times 1 over k, which is the same as 2 over k. And the k cancels there to give you 1 over k. 1 over k minus 2 over k is equal to minus 1 over k. Okay? And then minus 1 over k well, you can see that if k was equal to 1, it would be equal to minus 1. Alright? But if k was anything bigger than 1, it would be minus of something less than 1, so it would be bigger. So this shows you if k is anything bigger than 1, the minimum the minimum value will always be strictly bigger than minus 1. Okay? Maybe we could summarize that a little bit. So we tried some values of k, and when we tried them, we figured out how to find the general way of doing it. Okay, and so basically anytime you have a quadratic equation like this, so the graph of a quadratic equation kx squared minus 2x, we found the maximum or the minimum value. The minimum value occurs at halfway between the intercepts, and the intercepts are gotten from factorizing, which is x equals 0 and x equals 2 over k. Okay, so 0 and 2 over k. So that means the minimum has to occur at 1 over k. Okay, and so what the minimum is, then you just sub in x equals 1 over k here. Okay, so if you sub in 1 over k into this expression, you get 1 over k times k, which is 1 minus 2. So 1 minus 2 inside, and you get 1 over k outside. So this will just be negative 1 over k. Okay, and negative 1 over k is greater than negative 1. Okay? And notice that we have to assume k is greater than 0. It basically happens when 1 is greater than, you can think about it and just get the answer, or you could just manipulate this. So 1 is greater than 1 over k, and then k is greater than 1. Okay? So that would probably be the sort of the streamlined version of it, but you see the idea can come from specializing k and drawing some pictures.